Hi there, my name's Adrian Stein and this is my pitch for a device I'd like to create for my embedded system development project. I'm a frequent cyclist, in fact I don't even own a car, and I'd like to create an embedded device to help improve safety for cyclists. Using a bicycle is healthier and better for the environment, but unfortunately cyclists have very real safety concerns because we share the road with huge vehicles often going much faster than us. It's something that's certainly in the back of my mind when I'm cycling around with my kids. Cyclists are often treated as a bit of a nuisance and not treated with enough caution on the roads, not to mention adequate infrastructure. So the problem domain I'd like to tackle is cyclist safety, and with the number of cyclist deaths and injuries, there's definitely room for improvement and a market for products that reduce the chance of cycling accidents. By embedding an internet-enabled safety system into a bicycle, we can improve cyclist and motorist awareness of their proximity to each other. We can also immediately report accidents to an emergency contact and collect data about sections of road which are particularly dangerous for cyclists. The bike safety kit will tackle the safety problem in several ways. One, by improving cyclists' awareness of their surroundings, including parked cars and rear approaching vehicles. Two, improving driver awareness of cyclists with a high visibility LED display. Three, immediate crash reporting to improve accident response times. And four, collect safety data and give feedback for infrastructure improvement. Now, to help keep the project flexible, I've split it into a number of phases, with the essential features built first and more complicated features left until later, depending on how the prototype goes. Now, just as a starting point, we would have a particle photon attached to 5 ultrasonic sensors mounted to the bicycle, 2 on the rear and 2 at the front. The sensors at the rear would serve as a warning system for cars approaching from the rear, and the 2 sensors on the front would warn cyclists when they are too close to parked cars, which may open their doors. The prototype will use 4 LEDs and buzzers mounted to a dashboard visible to the rider, which indicate which sensor is firing. When the distance is sensed as less than a meter, which is the government's recommended safe passing distance, the LED will flash and the buzzer will beep. For the rear sensors, the distance will be increased to 3 meters to give cyclists advance warning of rear approaching vehicles. When the sensor records an unsafe distance, the particle photon will trigger a cloud function that sends the data to ThingSpeak. For phase 2, we add an LED strip to the rear of the bicycle which flashes when the system is on. When it senses vehicles within proximity, the flash frequency is increased to help improve driver awareness. In phase 3, we add a gyroscope. This can help us to report accidents by detecting whether a bicycle is upright or lying down. Laying a bicycle down is something rarely done unless a rider has fallen off. When a fall is detected, the gyroscope triggers a particle cloud function which sends a text message via IFTTT to an emergency contact. By detecting accidents early, we can alert authorities sooner and avoid injury scenarios where the rider is unable to call for help. We will also be able to send the accident report to ThingSpeak, which will contain the gyroscope and accelerometer data, and we can also see if any unsafe proximity was detected prior to the time of the accident. Now, if the above features work well, we can extend the project to increase frequency and change the color of the LEDs as a vehicle approaches. This will help driver and cyclist awareness. We can also add GPS data to the emergency contact alert and also send that data and collect it to report hazardous road sections to council. The software that we need is going to be the particle platform, custom C++ code to run the devices, ThingSpeak to collect data, and IFTTT to send emergency messages. The custom code will detect data from the distance sensors and gyroscope, as well as controlling the LED safety lights. When action is required, it will trigger the warning system and the particle cloud functions. For our hardware, we need a particle photon, ultrasonic sensors, a gyroscope, LED lights, and buzzers. Thank you for listening.